Lesson 10-5, solving quadratic equations by completing the square. So completing the square, you can see I have a quadratic here. Completing the square, we're going to put it into this kind of format. How do you do that? To complete the square for any quadratic expression of the form x squared plus bx, follow the steps below. So step 1, find 1/2 of b, the coefficient, which is the coefficient of x. Then you're going to square the results from step 1. So really, it is b divided by 2 and then square it. And then you're going to add the results of step 2 to x squared plus bx. And you're going to do that on both sides, like you see down here. And then you're going to have a perfect square trinomial in which you can now use to solve for the solution. For an example, it says find the value of c that makes x squared plus 8x plus c a perfect square trinomial, and then use the complete the square algorithm to solve. So I need to make that into a perfect square trinomial. So again, this is my a, this is my b, and this is my c. So I use the formula b divided by 2, and then I square it. So my b in this case is 8. Divide that by 2, and then square it. 8 divided by 2 is 4. 4 squared is 16. So my equation would be x squared plus 8x plus 16. With 16 being our c, because if I could factor it, this would be x plus 4 squared. The second one, I have my b is negative 18 divided by 2, and I have to square it. Half of negative 18 is negative 9. Negative 9 squared is 81. So my quadratic would be x squared minus x squared plus 81. And if I were to factor this, this would be x minus 9 squared. But for these two problems, when they're just saying identify the value of c, this would be our c. One more from example 1, I need to find c. So I take my b divided by 2, and I square it, which will be 40 divided by 2 squared. 40 divided by 2 is 20. 20 squared is 400. Example 2, now you're going to complete the square, which means you're going to be finding out what x equals. So to complete the square, I need to make sure that it's x squared minus 10x, and I need to find the c here. But in order to do that, I need to subtract 14 on both sides. So that's going to make this equal to a negative 9. Now to complete the square, I take my b divided by 2, and I square it. Half of negative 10 is negative 5. Negative 5 squared is 25. So now this is 25. But if I add 25 to the left-hand side, I have to add 25 to the right. So the left side is a perfect square trinomial. So that's x minus 5. And you'll notice that when I find half of b, that matches what's in my parentheses squared. And then on this side, negative 9 plus 25 is 16. Now this is from lesson 10-4 that we use the square root property. So to undo a square, I find the square root, and I'm left with x minus 5 equaling a positive 4 and a negative 4. Add 5 to both sides. X would equal 9 and positive 1. Next, again, I'm going to subtract 200 on both sides and then rewrite what I have. So I have x squared plus 26x plus blank equals, and 32 minus 200 equals a negative 168. Okay, so I take my b, 26 divided by 2, which is 13. 13 squared is 169. So I put 169 here. And this is a perfect square trinomial, which would make it x plus 13 equaling 168 plus 169 is 1. To To undo a square, I find the square root of both sides, and I'm left with x plus 13 equaling a positive 1 and a negative 1. Subtract 13 on both sides. X would equal a negative 12 or a negative 14. Example 3, now you're going to be solving an equation when a is not equal to 1. So how are you going to do this? The very first thing you need to do is you have to make sure that the coefficient in front of x squared is 1. So you're going to divide everything by the leading coefficient, every term by the leading coefficient, so it equals 1. Then you can complete the square. So an example here. First thing, I have negative 4x squared plus 32x minus 72 equals 0. I'm going to divide everything by negative 4. And I'm left with x squared minus 8x plus 72 divided by 4 gives you 18 equaling 0. Okay, so I'm going to subtract 18 on both sides. So then I can complete the square. So I have x squared minus 8x plus blank equaling negative 18 plus blank. Whatever I add on one side, I do on the other. So my b is negative 8. Divide that by 2 is negative 4. Squared will give you 16. So I add 16 to both sides, and I'm left with x minus 4 squared equaling a negative 2. Now, to undo a square, I find the square root of both sides. But I cannot find the square root of a negative number because there's not a number I can multiply by itself to give me a negative. So once you have a radical or a square root, a square equaling a negative number, the answer is always no solution. We cannot solve it from there. Next example, divide everything by 3 so I can complete the square. So now I'm left with x squared minus 4x minus 5 equaling 0. I'm going to add 5 to both sides. So now I have x squared minus 4x plus blank equaling 5 plus blank. To complete the square, I take my b, negative 4, divided by 2 is negative 2. Squared will give you 4. So now I have x minus 2 squared equaling 9. Undo a square, I find the square root, and I'm left with x minus 2 equaling a positive 3 and a negative 3. Add 2 to both sides, and I'm left with x equaling 5, or it can also equal negative 1. Next is find the maximum or minimum value, which really means find the y coordinates of your vertex. So how are you going to do this when it's in vertex form? You're going to complete the square to write the function in vertex form, and then you're going to identify the axis of symmetry and the extrema based on the function in vertex form. When the leading coefficient is positive, the parabola will open upward and the vertex will be a minimum. When the leading coefficient is negative, the parabola will open down and the vertex will be a maximum. Then you solve for x to find the zeros, and the zeros are the x-intercepts of the graph. And then you can use those key features to graph the function. So this first one, I need to write this in vertex form, so then I can identify the axis of symmetry, the extrema, and the zeros. We're going to complete the square. So I have x squared minus 2x plus blank. Here I'm just going to add 5 to both sides. Remember my y right now is 0. So that means I have 5 plus blank. So I take my b, which is negative 2, divide that by 2, then square it, will give me 1. So I add 1 to both sides, and now I have x minus 1 squared equaling 6. Now to put this into vertex form, I'm going to put this plus y here in here, just because in vertex form we're going to have the y. So I guess I could put this plus y here. So when I subtract 6 on both sides, I'm now left with y equaling x minus 1 squared minus 6. And why is that important? Because this 1 and this minus 6 is my vertex. So my vertex is actually at negative 1, not negative 1, 1 and negative 6. Because this is my h and this is my k. And if I know my vertex, I know my axis is my x coordinates of my vertex. So x would have to equal 1. And then to find my zeros. Find the zeros. Again, I could finish completing the square on this one. So if I didn't put it into vertex form, I end up with x minus 1 squared equaling 6. Now I find the square root of both sides, and I'm left with x minus 1 equaling the square root of 6. So the square root of 6 would give me 2.45 and a negative 2.45. All I need to do is add 1 to both sides. And now I'm left with 3.45. And negative 2.45 plus 1 gives me a negative 1.45. So my zeros are right here. Now I can graph all my points. So I have a point at 1, negative 6. That's my vertex. I now have my zeros at negative 2.45. So that would be roughly here. And my x is at negative 1. My x is at negative 1.45. So that's roughly here. And then 3.45 would be roughly here. And then I can graph my parabola. You could also do that on your graphing calculator. That would be my graph. Next, write y equals x squared minus 8x plus 15 in vertex form and identify the axis of symmetry, the extrema, and zeros, then use the key features to graph the function. Now, I could just graph that on my graphing calculator and then use that to find my zeros, but that won't help you to put it in a vertex form. So for this one, I'm going to put it in a vertex form, find my zeros, and then I'll show you how to put it on your calculator. So 8 squared x squared minus 8x plus negative 8 divided by 2 is negative 4 squared will give you positive 16 equaling. And I have to subtract 16 on both sides. So I have 15, and then I have to add the 16 to both sides. So right now I have x minus 4 squared equaling positive 1. Now to find my zeros, I find the square root of both sides, and I'm left with x minus 4 equaling a positive 1 and a negative 1. Then I can add 4, and I'm left with x equaling 5 and x equaling a positive 3. So those are my zeros. I need to write my equation in vertex form. So I'm going to use this part. So I have x minus 4 squared equaling 1 plus my y. Remember I had a y here. So if I add that there, now I just subtract 1 on both sides. I now have y equaling x minus 4 squared minus 1. So my vertex is my x is 4 and my y is negative 1. Now if I go to my calculator now, and we're going to graph this, I'm going to graph this original one that they have here. So x squared minus 8x plus 15. And I'm going to do second graph to see my table of values. My vertex is at 4, so if I want to go to 4, so you can see I have 4, -1 here, which is my vertex because on each end they repeat. My zeros, x is 5 and x is 3. Now if I hit the graph button, you can see my graph right there. Now let's go to here. Let's plot those. So 5 and 3. And then I have 4 and -1. So here's my parabola. Now, example 5, finding a maximum. Here's where you can put this in your calculator to find it, and I have all the steps here. I will also use your show you how to do it on the calculator. But first, we have to write this in vertex form and identify those key features. So I can't have a leading coefficient besides 1. So I divide everything by -2. So now I have x squared minus 10x plus blank, and then 42 divided by -2 is a positive 21. So if it's a positive 21, so let me do positive 21 equaling y. I'm going to subtract 21 on both sides. And now I have a difference. I have a perfect square trinomial here. Actually, now I have to complete the square. Sorry. So I have x squared minus 10x. Half of -10 is -5. -5 squared is 25. So plus 25, and I add 25 over here. This is going to equal y plus 4. So now I have x minus 5 squared. Now if I subtract this 4 back on both sides, I now have a minus 4 equaling y. This is vertex form. From that, I completed the square. This piece right here, x squared minus 10x plus 25 is right here. Then I subtracted the 4 on both sides, and I have vertex form. So my vertex is now 5, -4. My x-intercepts, my zeros. So I'm going to go back to where I have this y here. That's going to be a 0. So right now, instead of this y in vertex form, I have x squared, or not x squared, I have x minus 5 minus 4 equaling 0. I'm going to add 4 to both sides. X minus 5 squared equaling 4. Find the square root of both sides, and I'm left with x minus 5 equals 2 and a -2. Now I can add 5, and I'm left with x equaling 7 and x equaling 3. So my zeros are 7 and 3. The axis of symmetry, so the axis is my x-coordinate, so x equaling 5. The extrema, what's my maximum, my height? So the maximum is y equaling, in this case, my maximum would be -4, but my x-coordinate would be 5. So really when you're finding the maximum, you're actually finding the vertex. So now let's go to our calculator. And we're going to type that equation in here. So -2x squared plus 20 minus 42. And if I hit the graph button, let me go back to see if I have it. I forgot the x here. So put an x and then plus 42. So you can either put it as vertex form or standard form, it'll still show the same thing. Let me go back to here. Negative 2x squared plus 20x plus 40. There should be a minus 42. So minus 42. Then graph it. There we go. Now to find the maximum, if I hit second trace, the maximum is number 4. Hit enter, and then it says left bound. I need to go to the left side of the vertex. So anywhere on the left side, hit enter. Right bound, so I go to the right side. Anywhere over there, hit enter. Hit guess, hit enter a third time, and it'll tell me my vertex, which is, when they say 4.9999, that means 5. And then I have my y coordinate at 8. Now that one is different than what I have here. So let me see what I did wrong on mine. All right, I see the mistake that I made. If I go back here, now I did everything correctly to find the zeros, but I didn't do everything right to write my equation like that in vertex form. So if I come back to here, so let me, when I was completing, I go through the same steps to find my zeros, but to write it in vertex form, I'm not going to divide by negative. I'm not going to divide everything by -2 to start off, just only on the one side. So to start off again here, I'm going to add 42 to both sides. So now I have, on one side I have -2x squared plus 20x equaling positive 42. Now on this side, I'm going to factor out a -2. That leaves me with x squared minus 10x, and then I have to do plus a number equals 42 plus a number. Just because we have a dilation in here, and the dilation is a -2 here, and there's a reflection involved. So now I complete the square, so -10 divided by 2 is -5. -5 squared is 25. So if I put a 25 in here, but because I factor out a -2, I have to multiply -2 times 25 in order to do the same thing on both sides. Because I'm not just adding a 25 on the left side, I'm actually adding a -50. If I add a -50 over here, I now have a perfect square trinomial, which is x minus 5 squared equaling 42 plus a -50 is -8. So now to get this all on one side, because remember there's a plus y over here, now I add 8 to both sides, and my vertex form would be y equals -2 times x minus 5 squared plus 8. And so my vertex would be 5 and then 8. And as you can see on my calculator right here, that's what I have as my vertex. So the maximum, your y would be 8. So just keep that in mind when you're writing in vertex form. You do need to keep in consideration your a, that dilation. But for completing the square, you don't have to worry about that part. You just have to divide everything by the leading coefficient and do it as normal. So let's try another one of those. Y equals -x squared plus 14x plus 32 in vertex form. Then we need to identify the axis of symmetry, the extreme and the zeros. Then use the key features to graph the function. So the first thing I'm going to do is just write it in vertex form. So right now I have y equaling a negative, and I'm going to negative x squared plus 14x plus 32. So I want to get this 32 to the other side by subtracting 32. So now I have y minus 32, and then I'm going to have to add something over here, equaling, I have a negative, factoring out negative 1, and then I have an x squared minus 14x, because I divided out a negative 1 from 14. Half of negative 14 is negative 7. Negative 7 squared is a positive 49. So now if I'm adding, if I take a negative 1 times 49, that's a negative 49. So I'm actually adding a negative 49 to both sides. That's going to give me y minus 32, negative 32 plus a negative 49. That gives me a negative 81. So minus 81 equaling, I have negative 1 times x minus 7 squared. Now I can get x by itself by, or y by itself by adding 81 both sides. So my vertex form would be y equals negative x minus 7 squared plus 81. So right now I know that my vertex is now at 781. And my axis is at x equaling 7. And I have a maximum at y equaling 81. Now I need to find the zeros. So to find the zeros, I go back to my original problem that I had. So I have y equaling negative x squared plus 14x plus 32. So I'm going to make this, divide everything by negative 1. And then y is 0. So I have x squared minus 14x minus 32. So I'm going to add 32 to both sides. So I have 32 plus a blank when I complete the square equaling x squared minus 14x. Half of negative 14 is negative 7. Negative 7 squared is 49, so positive 49. So I'm going to add 49 to both sides. And now I'm left with 32 plus 49, which is 81, equaling perfect square. I have x minus 7 squared. So to undo it, find the square root of both sides. So that gives me positive and negative 9. And then I have x minus 7. So I add 7 to both sides. So my zeros would be x equaling 16 and x equaling a negative 2. So now I can take my calculator, I'm going to graph it on here to make it a little bit easier. So now I have my y equals, I'm going to plot my equation in there. So negative x squared plus 14x plus 32. I'm also going to put my vertex form in here. So you can see that it's the same. So my vertex form is negative x minus 7 squared plus 81. I'm going to change my Windows settings. So my maximum, I'm going to say, I'm going to put, since I know it has to get at least to 16, I'm going to make this 20. I'm going to count them by twos. My Y minimum, keep there. Maximum, I know it has to hit at least 81, so I'm going to just make this 100. Counting these by tens. And then if I hit graph, here's that first one that I did. Second one should be the same, so that's why you don't see a second one on there. Now if I hit second, trace, number 4, the maximum, hit enter, go to the right side, hit enter, enter a third time, and you should see here's your 7 and here's your 81, which that's what I had as my maximum, where my vertex has 7 and 81. Example 6. So now you're going to use the extrema and the key features in a word problem. Suppose the path of a golf ball hit on the moon can be represented by y equals negative 0.001 x squared plus 0.248 x, where y is the height of the ball in meters and x is the horizontal distance in meters. Determine the maximum height of the golf ball and the horizontal distance it traveled. So to do this one, I have y equals negative 0.001 x squared plus 0.248 x. So we need to find the maximum height of the ball and then the horizontal distance it traveled. So really, the maximum is our vertex, and the horizontal distance, it goes from 0, so starting at 0, to whenever it hits the ground. So to do that, the quicker way, let's just use our calculator here. We're going to type in our equation. So I have a negative 0.001 x squared plus 0.248 x. I'm going to hit zoom, number 6. I got to go back to delete this other one here. And let's change my Windows settings to, I'll make the x maximum, I'm going to make this 100. I'm just guessing here because I'm not sure exactly how far it's going to go. The y minimum, I'm just going to keep that at negative 10. The maximum, the heights, and I'll just be generous and put it at 100. Count these by 10. And then let's see, graph. Okay, I haven't seen where it hits the ground, so I'm going to go back to my x maximum and let's make this, I'll make that 500. And then count this by 100s. Now let's try it. There you can see it. So we want to find our maximum. So second trace, intersect number 5. I need to go to the left-hand side of the vertex. Actually, sorry, second trace maximum. So number 4. Left bound, left side. So I'm at enter, go to the right side. Hit enter a third time. It tells me it reaches a height of 15.376 meters. So the maximum would be 15 point, we could just say, yeah, 15 points. We'll do it to the nearest hundredth, so 15.37. And then the distance it traveled. So to find out the distance it traveled, I want to go from 0 to here. So I want to find out what this coordinate is here. So if I go second trace, I need to find the 0, so number 2. Left bound, it means above the x-axis, so I'm going to hit enter. Right bound means I have to go below. So I'm just looking at my y coordinate until it gets in the negatives. There it's in the negatives right here. Hit enter a third time. When y is 0, x is 248. That means from the origin to the zero is 248. So the distance, and this is horizontal, would be 248 248 meters. Now this one you could have completed the square, but I think for this one the easier way to do it would be using your graphing calculator to come up with your maximum and the distance of travel. And our last one, a flare is launched from the deck of a ship. The function y equals negative 16t squared plus 128t plus 36 represents the height of the flare in feet after t seconds. Determine the maximum height of the flare and how long it takes the flare to reach the surface of the water. Round to the nearest hundredth. So we need to find the maximum height and then the zero, and it has to be the positive zero. So again, I'm just going to use my calculator here. Go to my y equals, and I type in negative 16 x squared plus 128 x plus 36. Now I don't know the other, like the Windows settings, so I'm just going to estimate here. I could just keep it as is. I don't think it would have gone up 500, but we could just keep it there. So if I hit graph, then we go back to this one. Let's make the x maximum smaller. So let's make this 50. Count this by tens. And then let's try it now. Okay, so we can see a little bit, but we can only see part of it. We don't see when it comes down. So let me go back to my Windows. Let's go 100. We did 100. Let's do 75. The maximum, let's do 200. And then change this to 25. Now let's see. Oh, I forgot to put the x in here, so sorry. So x squared plus 128x plus 36. Now let's see if we graph it. You can see that a little bit right here. So let me just change my Windows setting a little bit. Let's change this to 50. Maximum, let's go 300. There we go. Now the maximum. Second trace, number 4. We want to go to left bound. Have to go the other direction. Okay, left bound. I'm on the left side now. Hit enter. Go to the right side. Hit enter. Enter a third time. So our maximum height it goes is 292 feet. And then how long did it take to reach the ground? So now I go to second trace. I want to find the zeros, so number 2. And I need to go to the right-hand side. So above the x-axis, go below the x-axis, hit enter. And when y is 0, x is 8.27. So it says to the nearest hundredth, so 2 decimal places, 8.27 seconds. That is how you can use your graphing calculator to find the maximum and the